So this lesson is the next part to our recursion unit. Now you remember in the first couple of weeks of this topic, we were learning about obviously recursion, but about arithmetic sequences. Yes, arithmetic. Does anyone remember what does arithmetic mean? Adding and minusing, yep, or adding plus, minus, subtract in a sequence. Okay, so when you have, and the number that you're adding and subtracting by is called the common, starting with D, the difference. Okay, now obviously in all of our recursion, it's not always just about adding and subtracting. Okay, we're going to now look into the next part, which is our geometric sequences. Okay? So AE on geometric sequence. And the intention for today is for you guys to understand, I'm going to stand here so you can hear it, understand the basis of your geometric sequences. Okay, you understand already that arithmetic is all about adding and subtracting. Geometric is a little bit different, okay? But it's still a very, very similar principle. And in terms of our criteria, or what you need to be able to do today, is calculate your common ratio. Okay, now you might be already having ideas of what that is. So if common difference is adding and subtracting, or that number that you're adding and subtracting by, common ratio is most likely something else. Okay, and you need to be able to generate a geometric sequence and also graph a geometric sequence, which we've already been doing with arithmetic sequences, being able to graph it. So here we go. For 8E, on geometric sequences, we're going to look at the common ratio. Okay, right there. So keyword there is common ratio. Okay, instead of common difference, we're using now common ratio for geometric sequences. So when you're thinking of geometric sequence, think common ratio. And in a geometric sequence, as we've been doing in arithmetic, it's adding and subtracting. For geometric, it's all about multiplying. Now, you might think, where is the dividing part to this? There is division, okay, don't get me wrong, that is still part of geometric, but in year 11 and with a lot of the numbers that we use, we're just going to be doing multiplication. And the reason being is whenever you multiply, think about this principle. If you multiply with the number 1, what happens? Nothing. It stays the same. So 1 is your basis, okay? So what happens if you multiply with a number that's greater than 1? It's going to
Multiply.
increase, okay? But that's cool. But then what happens when you multiply with a number that is less than 1?
Decreases.
It decreases, okay? So if 1 is our basis, okay, and we're going to keep using multiplication, any number, so let's say my ratio, if it's greater than 1, is going to increase. Okay, keep that in mind. If your ratio is less than 1, it's going to decrease. So when you multiply with a number that is greater than 1, it's going to increase, but if it's less than 1, it's going to decrease. That's why we don't really use divide, because when you divide, obviously it gets smaller, right? But instead, we're just going to multiply with smaller numbers, or decimal numbers. Yes? Yes, so if r is less than 1, it's going to decrease. If r is greater than 1, it's going to increase. So r just means common ratio. Okay, and the reason why we do this is because in financial maths, okay, you're going to be using a lot of decimals. So yeah, just you get used to that. You'll be seeing a lot of decimal numbers in our geometric sequences. Okay, so in your geometric sequence, each new term is made by multiplying, okay, with the previous term, and that number that you multiply with is called your common ratio, as we have discovered. And repeating that will generate a recurrence relation or a sequence. So here's a sequence, for example. Term 1 is 2 and the common ratio is 3. So to get the next number, it's going to be 2 times 3, which gives you 6. And then you repeat the process. 6 times 3 gives you 18. 18 by 3 is 54, and then so on and so forth. Okay. So in this sequence as well, down here, same thing. Remember, when you multiply with a number less than 1, so what's this an equivalent of, guys? Half as a decimal number. 0.5, yeah? So it's multiplying by half, which means it's going to go down, get lower and lower. So I don't think there's numbers here. Numbers are blocked out, but I'll come up with my own numbers. Okay, let's say term 1 is 80. Let's go here. So if I've multiplied that by a half, what happens? 40. multiply that by a half, 20. Another half, 10. And if I do it again, 5. Okay? And then so on and so forth. So it's just based around, for geometric sequence, multiplying. Not really dividing, but it is still part of it. Okay. And you can see how if you multiply with a number less than 1, so remember this, okay, the ratio is 0.5, yeah? Half is the same as 0.5. Just keep that in mind. Okay, let's move on. So how do we calculate the common ratio? So for any geometric sequence, now this is the next rule I want you to put in the second page of your booklets. Okay, the common ratio rule. I'll rewrite it here, and this is how we find the number that you're multiplying by. So the other rule is R, which means common ratio. So it's basically any term divided by the previous term. So instead of minus the previous, it's divided by the previous.
Put it on the second page, yeah?
Yes, put this rule in the second page. So, and when you use it is to calculate, it's called the common ratio rule. I'll just write used to calculate common ratio, sorry. Used to calculate. So if you need to calculate the common ratio, use this. Now, I'm going to add a little footnote here, or a little bit. Common ratio for, in brackets, just basic geometric sequence. Okay, basic geometric sequence. Now, the reason why I say this is because I don't want you guys to get confused with the other common ratio that you're going to be finding, okay, when it comes to percentage changes. This is just for your basic, when you've got like a sequence that's given to you already, and it asks you to calculate the common ratio, this is what you use. Okay, but later on, you're going to have percentages, so it's going to be slightly different. Okay, so this rule here, finding common ratio, but only for your basic geometric sequences. Okay, so put that in your second page, please. And also, just keeping in mind that when your common ratio is, I don't like this. It should actually be 1 there, but that's fine. But remember, keeping in mind, if you're multiplying with a ratio greater than 1, it's going to increase. And if it's less than 1, it will decrease. Okay. So let's do these for example. Let's find the common ratio for these sequences. Remember, whenever you have a sequence, it's always good to label it, just so you know what you're working with. Okay. So this is T1, T2, T3, T4, and we're going to find the common ratio. So remember, the rule for the ratio is any term.
It's flickering, it's pissing me off.
Sorry, yeah, it's the screen. Divided by the previous. Okay, so any term divided by previous. So I might go T3 divided by T2. T3 divided by T2. And that will be 48 divided by 12. So R equals 48 divided by 12. And off the top of my head, the common ratio should be 4. Okay, so nice and easy. You're multiplying by 4. Now, if that's the case, so if you're multiplying by 4, is the number going to increase or decrease? Increase, yeah, because more than 1. Right, and then this one here. I was about to say shh, but that's next door. Alright, so here, common ratio, same thing. Now, you don't necessarily have to keep writing this, okay, each time when you do working out. I just do it for the sake of it so people don't get lost, yeah? But at least, if you can, if there's no labels for the term, do that. So you're not confused with what you're working with. Okay, so here, the common ratio, remember, is any term divided by previous. Anyone want to pick any? Give me one. T3 and T2. Okay, so T3 divided by T2. Nice and easy. So it's going to be 4 divided by 8. Therefore, the common ratio is a half or 0.5. And really quickly, will this be, so if I'm multiplying by a decimal number less than 1, Is it going to increase or decrease? It's going to decrease. Okay? Easy. Alright, so let's see if we can recognize which of these are geometric. So remember, to calculate if something is geometric, it has to be multiplying by the same amount, not minusing or adding. It has to be multiplying. So looking at the first sequence, if I try to calculate the common ratio, start with your term numbers. Okay, so for example, I might go T4 divided by T3. So that'll be 350 divided by 50, and the common ratio for that will be 5. Okay, all right, fine. That's cool. Let me test it on another one. Let's try it on T3 divided by T3. So T3 would be 50 divided by 10, and that also equals 5. So it's looking like the first one is most likely a geometric sequence. I'm going to try one more just to test it. It's good to test at least more than 2, because you never know what they've thrown at you later on. Okay, you might be like the first number could be like 1. Okay, later on, and you might think that, oh yeah, everything else looks geometric, but not necessarily. 1, so that should be 10 divided by 2, which also equals 5. So, yep, this one is geometric. And I can see it is geometric because the common ratios are all 5. Okay, so that one works out. Let's try the next one. This one might not be, but we'll see. So let's try T1, T2, T. Is it? Let's have a look. So let's go first one, let's go T4 divided by T3. So that's going to be 36 divided by 18, which equals 2. Okay, cool. Let's try another one. Let's do T3 divided by T2. So that'll be 18 divided by 6, and that equals 3. So that already, you only need to do that. You don't need to do any more. That's already not geometric.
It looks geometric.
It does, yeah, but if you test it, multiplying by the same number. Whereas arithmetic is adding or minusing by the same number. Okay, so that's not geometric. Alright, on your CAS, get your CASs out. I'll show you really quickly how to get a geometric sequence going. And then I think that might be it for our graphing. And then that's it. Okay, so let's get our CASs out. Any questions so far on how the geometric sequence works? It's just multiplying, yeah? But just keeping in mind that the number you multiply is called the common ratio, and if it's greater than 1, Bobby, what happens if you're multiplying with a number that's bigger than 1? We're starting with I.
Increase.
Good. And if it's less than 1, it's a decimal number.
Increase.
Good. Okay, so that's just a couple of principles to keep in mind. So on your CAS, add calculator. Get your calculators out, boys. Let's go. Yeah, so always start by writing down the first term. Okay, so let's say, for example, give me a first term, guys. Any number? 5. Okay. And then common ratio? 3. Okay, so you wrote 5, and then now you go times 3. And then as you keep pressing enter, it will generate the sequence for you. Nice and easy. As much as you need.
Oh my goodness gracious!
Right, shh. And also keep in mind, let's say for example, so start with a number. Just start again. So start with the first number. Let's say first number is 9. And then you press enter. And then your common ratio is, for example, times 2. So you write times 2, and then if you keep pressing enter, it will generate the sequence. It is exactly the same as the common difference or arithmetic. And another example, let's say my first number is 900. Okay, and it's going to be a common ratio of 0.87. It's going to decrease. Okay, each time. Okay, so that's pretty straightforward on the CAS. Next part, and the final part before you guys start your textbook work is now graphing geometric sequences. Okay, so for this one here, let's go to this example, guys. Example 13. You've got a geometric sequence. Okay, and we're going to graph it. So according to this, we need to find the next term. Show the first four values in a table. So your table of values. Plot the graph and then describe it. So let's do that. So I'm going to write my terms here. 2, 6, 18. I know that that's T1. This is T2. That's T3. Okay. So technically, what a lot of you guys did in your CFATs or your SAC, sorry, your CFAT, is you just worked it out in your head. What's the next number? Okay, but you got to show your working out. Okay, so show full working out. Let's do the common ratio. Remember the rule for the ratio is any term divided by, thank you, previous term. Which one should I use? Nick, give me any number. Okay, 18 and 6, so we'll go T3 divided by T2, which is 18 divided by 6. Good. Okay, so 3. So I'm looking for T4. Good. So as working out for it, it would be T4 equals T3 times 3. So T4 is 18 times 3, which equals, did you say 54? Good. 54. Easy. There's your first, there's the fourth term, 54. Part A. Cool. Part B, show the positions and values of the first four terms in a table. So let's put that in a table of values. I'll just scroll to the side here. So table of values, so part B. So this is part A. Show full working out, please. Yeah. For part B, though, you've already got the first four numbers, so you don't need to show any working out for it. But make sure that you put the correct variables on the correct sides. So n goes on top, so the term number. Tn represents the term value. Alright, just understand the difference there. So you got 1, 2, 3, 4. Good. So 2, 6, 18, 54. So 2, 6, 18, and 54. Cool. Part C, graph that. Nice and easy. Again, it's similar to the arithmetic. But what do you guys think is going to be the difference here with the graph? So for arithmetic, the line is going to be straight. But what do you think will happen for geometric? It's going to... What did you say, Leah? It's going to curve. Good. For your geometric lines, it will curve.
Mount curves like a spiral.
No, that's not right. 2.
Fibonacci! This is Fibonacci.
Sorry? Oh, Fibonacci. Sort of, but not quite. Okay, and the values here. Shh. We'll go up by 10s for this one. Okay, first number. So, like Leah said, this is going to curve because of the way that the numbers multiply. It gets bigger and bigger and bigger each time. Whereas for arithmetic, it's straight because you're just adding the same amount each time. Okay, so this is not going to be linear. So, 1, 2, 2 is about here. This is going to be. Let me zoom in a bit. So 2. This one is 6. 18, which is about here. And the other one is 54. So 4. So notice how the line is not linear, but it actually curves upwards like that. Okay, it curves up.
Oh, we're doing curves now.
For geometric sequences, yes, it curves.
So you said to always draw the line no matter what.
Yeah, always draw the line.
I'm proud about
It's a
it.
good idea to do that. And describing the graph. So what would we say that for that, guys? Tell me the strength. Actually, can't really tell the strength, but what's the form in the direction? Non-linear. What direction? So it's good. Non-linear, positive. And if we had the R value, you could tell the strength, but I would say, let's just say it's strong. Could be moderate, but we don't have the R value. That's the only thing. Yes.
Like,